About vectors. So vector is basically a specific representation of something that's got magnitude and it has an angle. So it basically has magnitude and a direction. Okay, so a good representation of a vector is normally a specific variable like u, for instance. Sometimes it's like a bold u that they use. Sometimes they even use like a little arrow to show that this is a vector. So for our purposes, we're just going to use a u, and that is going to represent our vector. So in our vector, we're going to represent our vector with a coordinate. So if we look at a plane and we say that the vector is 2, 1, so it will be 2 on the x-axis and 1 on the y-axis. So that would be our point to which the vector moves. So we draw a line from the origin. That's not a good line. From the origin to our point with a little arrow. So the arrow shows that it's got direction. Okay, so we can also represent a vector with two coordinates, with the x and the y. Another way to represent this is going to be 2i plus 1j. So I indicates the x direction and j represents the y direction. Okay, so this is basically any quantity that's got magnitude and direction. A good example would be, for instance, which is something you're going to use quite a lot, is a force. If you look at a force, say 20 newtons, that's always in a specific direction. So it would be, for instance, if you look at something that hangs from a pulley, you'll always have a down direction that the force is maybe experiencing something's experiencing a force of 20 newtons. So this is quite common. You can have maybe a wire over a pulley, and then there's also 20 newtons in that direction. So we always use magnitude, which in this case is Newton, and in direction. So the direction could be down or right. In our case, we're going to calculate the direction from the x-axis. So just like any other coordinate system, if you look at trigonometry, we always move from the positive x-axis and we move around anti-clockwise to calculate the angle. Okay, so let's take an example of a vector. Let's say we've got a vector, and this vector has got a x value and a y value. Let's make this another color. We've got an x value and we've got a y value. So let's say this vector is v, and the x length is 3 and the y length is 2. So this would be 2 and this would be 3, and that's the vector. So we can draw a right angle triangle, and now we can do a few things. So let's see, how do we calculate the magnitude? So let's look at the magnitude of a vector. Okay, so the magnitude is basically, in this right angle triangle, is going to be the hypotenuse. So you might have guessed it, we can use Pythagoras. So we've got the vector v, which is 3, 2. We can say we want to get the magnitude of v. So we can use the absolute value symbols. So magnitude is always two straight lines around our variable, and that indicates magnitude. So remember, for Pythagoras, we're going to have the adjacent side squared plus the opposite side squared. So that's going to be our angle. 2 squared, and we must get the square root of these two. This would be then the square root of 9 plus 4, and that's going to be the square root of 13. So that would be the length of this side. So this is going to be square root 13, and that is the magnitude of our specific vector. Now we want to calculate our angle. So luckily we know about trigonometry, and this is the opposite side and this is the adjacent side. And if we have opposite divided by adjacent in trigonometry, we know we're going to use the tangent of the angle to get that value. So let's use that then. So we're going to say the tangent of the angle theta is going to be opposite, which is 2, divided by adjacent, which is 3. And then we can calculate the angle. So on your calculator, you'll see, if you use a Casio calculator, you'll see there's a little sign that says tan minus 1. So that's just above. So you're going to use shift tan to get to that on your calculator. Now in calculus, we can use arctan to represent this calculation. So the correct way to do this is to say theta is the arctan, which is basically the second function tan on your calculator, of 2 divided by 3. So now what we need to do is we need to take out your calculator. Just make sure that your calculator is on radians. If you're not sure what a radian is, go back to a video that I've uploaded on the channel that will show you what is a radian and how to use radians. So for now, what we're going to do is we're just going to say, on your calculator, we're going to say shift tan, and we're going to enter the fraction 2 divided by 3, and that's going to give you a value of 0.588 radians. Okay, so remember in the previous video we talked about radians, and we know that 1 radian is more or less approximate 57.3 degrees. So you can always just do a little calculation. This is about half of 1 radian. That's so it'd be in the order of about 30 degrees more or less. But we're going to leave it in radians. So we can always calculate the angle and the magnitude of a vector using these formulas. So the first one, for magnitude, we're going to use Pythagoras. And for the angle, we're going to use the tangent function. So the tangent of the opposite, which is always your y value. Let's just make it a different color. So for the angle, we're going to say it's going to be the tangent of the angle is going to be the y value divided by the x value. So it's always going to be the y divided by the x. So it's going to be 2 divided by 3 to get the angle of a specific vector. So remember, if we do the angles, it could be that the angle is in a different direction. So for instance, we can say we've got, let's take another example. Let's take u in this case, and this time we're going to put it like minus 3 and 5. Or let's make it minus 3 and 4. So if we draw this, we know that it's going to be, okay, let's draw this quickly. If we draw this, it's going to be minus 3 on the x-axis. That's going to be 3 in this direction. So it's going to be at minus 3. And 4 in the y direction. So that's going to be on 4. So there's our point. That's going to be minus 3, 4. And this is going to be our vector. So remember, we can draw this now. Let's just draw a little triangle quickly. So we know this is going to be 3, this is going to be 4. So let's look at the magnitude. So the magnitude, remember, is always the adjacent squared. So it could be minus 3 squared plus 4 squared. So you can see the angle doesn't really make a difference because the sign course, this negative squared is always going to be positive. So this is going to be 9 plus 16 square root, which is the square root of 25. So this would be 5. So we know that this magnitude is going to be 5. Same as this magnitude here. So let's look at the angle. Remember, we always use the angle as if it is in your first quadrant. So it's always going to be the tangent of theta is going to be the opposite over the adjacent. So it's 4 over 3. And to get the angle, we're going to say theta is going to be arctan of 4 divided by 3. Remember on your calculator to use the second function tan, and then put in your fraction, which is 4 divided by 3. And that should give you a value of 4.13. Okay. So that is the angle of the specific vector. Okay, so you can calculate the angle of any vector. So if we take another example, we can always use the remember, just like trigonometry, the first quadrant is going to be theta, the next quadrant is going to be pi minus theta, which is in 180 degrees minus theta. This is going to be pi plus theta, and the last quadrant is going to be negative theta. And we can use this to calculate angles in specific quadrants. Okay, so let's do an example of a quadrant equation. Let's say we've got another quadrant, so let's just get an example. Let's make a new page. Let's take this triangle. It's going to be in the fourth quadrant, and we need to get the angle. And let's say this is a right angle triangle, and let's say this is square root of 3, and this length is 1. So our coordinate, let's say our vector is w, and this vector is going to be minus square root of 3 and minus 1. Okay, so again, to get the magnitude, we use the absolute value. It's going to be the square root of 3, the minus square root of 3 squared plus 1 squared, and we get the square root of that. That's going to be 3 plus 1, and that's 4, and square root of 4 is equal to 2. Let's look at the angle. In this case, the angle is going to be opposite, so we say opposite of this angle is 1, so it's 1 divided by the square root of 3. So this is a special angle, so you'll notice if you do 1 over square root of 3, let's put that in the calculator, square root of 3, and you should get a value there. So this should give you 30 degrees, which would be pi divided by 6. Okay, so you can see this is for the first quadrant, but this is not in the first quadrant, so you notice that this would probably be in your, if you look at your little plane, this is going to be theta plus the angle. So the angle is actually going to be theta plus pi over 6. So this is going to be 7 over 6 pi, the angle. And that's how you calculate angles and magnitudes of a vector.